In the diagram below, not drawn to scale, AKLM and ASTJ are both rectangles. Given that AS is 3x centimeters, AJ is 2x centimeters, SK is 3 centimeters, and JM is 5 centimeters. Part 1 of the question: obtain an expression in terms of x for the area of rectangle AKLM. Well, area of rectangle AKLM is equal to length times width. Length of rectangle AKLM, so for calculation purposes, we shall assign it the side AM, and that is equal to 2x plus 5 centimeters. The width of rectangle AKLM, we shall assign this side AK, and that is equal to 3x plus 3 centimeters. Therefore, area of AKLM is equal to length times width, which is equal to 2x plus 5 centimeters times 3x plus 3 centimeters. So we will be multiplying 2x plus 5 times 3x plus 3. Using the distributive law to expand my brackets, 2x times 3x, that is equal to 6x squared. 2x times positive 3, that is equal to positive 6x. Positive 5 times positive 3x, that is equal to positive 15x. Positive 5 times positive 3, that is equal to positive 15. Simplifying my expression, 6x squared. I have 6x and 15x. I can add these two terms. 6x plus 15x, that is equal to 21x. And of course, I have positive 15. So the area of AKLM is equal to 6x squared plus 21x plus 15. And of course, I have cm times cm, that is equal to cm squared. That is my answer. Part 2 of the question: given that the area of rectangle AKLM is 60 cm squared, show that 2x squared plus 7x minus 15 is equal to 0. So, my first step is to take down the information presented to me. Area of rectangle AKLM is equal to 60 cm squared. Recall, area of rectangle AKLM is equal to 6x squared plus 21x plus 15 cm squared. We can therefore conclude the quadratic expression 6x squared plus 21x plus 15 cm squared is equal to 60 cm squared. Simplifying my quadratic equation, 6x squared plus 21x plus 15, positive 60 on the right, now becomes negative 60 on the left, is equal to 0. 6x squared plus 21x, positive 15 minus 60, that is equal to negative 45, is equal to 0. I notice that the coefficient of the x squared term is 6, the coefficient of the x term is 21, and my constant is negative 45. These numbers all share a common multiple, which is 3. So I can simplify my equation further. Dividing my equation by 3, 3 into 6x squared, that is equal to 2x squared. 3 into positive 21x, that is equal to positive 7x. 3 into negative 45, that is equal to negative 15. That is equal to 3 into 0, that is equal to 0. Therefore, we have shown that the area of rectangle AKLM is equal to 2x squared plus 7x minus 15 is equal to 0. And that is my answer. Part 3 of the question. Hence, calculate the values of x and state the lengths of AK and AM. Recall, the equation for the area of rectangle AKLM is equal to 2x squared plus 7x minus 15 is equal to 0. This is a quadratic equation, which will give us two solutions for x. In this example, I will be using the quadratic formula to determine the values of x. Quadratic expressions have the standard form ax squared plus bx plus c, where a is the coefficient of the x squared term. In this example, this is equal to 2, where b is the coefficient of the x term. In this example, this is 7, where c is our constant. In this example, this is negative 15. Now that I have determined the values of my coefficients and my constant, I can now use the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So my next step is to substitute the values of my algebraic variables a, b, and c into my quadratic equation. Therefore, x is equal to negative b, which is 7, plus or minus the square root b squared, which is 7 squared, minus, I will be using square brackets here because I'll be finding the product of 4ac, 4 times the value of a, which is 2, times the value of c, which is negative 15, close my square bracket, all over 2a, which is the value of 2. X is therefore equals to negative 7 plus or minus the square root 7 squared, that is equal to 49, minus square brackets 4 times 2, that is equal to 8. 8 times negative 15, that is equal to negative 120. All over 2 times 2, that is equal to 4. Simplifying my equation, x is equal to negative 7 plus or minus the square root 49 minus negative 20, that is equal to 169, all over 4. X is therefore equals to negative 7 plus or minus the square root of 169, that is equal to 13, all over 4. At this point, I have two solutions for x. X is equal to negative 7 plus 13 over 4, and x is also equal to negative 7 minus 13 over 4. Simplifying my two equations, x is equal to negative 7 plus 13, that is equal to positive 6 over 4. Simplifying my fraction, x is equal to 3 on 2. And x is equal to negative 7 minus 13, that is equal to negative 20 over 4. Simplifying my fraction, x is equal to negative 5. We just calculated the values of x. We need to now state the lengths of AK and AM. Recall that length is a scalar quantity, which means it cannot be negative. Therefore, the value of x, which we will use to find the lengths of AK and AM, is equal to 3 on 2. AK is equal to AS plus SK. AK is equal to 3x cm plus 3 cm. Recall the value of x that we will be using to find the length AK is 3 on 2. Therefore, AK is equal to 3 times 3 on 2 cm plus 3 cm. AK is equal to 3 times 3 on 2, that is equal to 9 on 2 cm plus 3 cm. Rewriting 9 on 2 as a decimal, AK is equal to 4.5 cm plus 3 cm. Therefore, AK is equal to 4.5 plus 3, that is equal to 7.5 cm. Now let's find the length AM. AM is equal to AJ plus JM. AM is equal to 2x cm plus 5 cm. AM is equal to 2 times the value of x, which is equal to 3 on 2 centimeters plus 5 centimeters. Therefore, AM is equal to 2 times 3 on 2, that is equal to 3 cm plus 5 cm. AM is equal to 3 plus 5, that is equal to 8 cm. So, we have calculated the values of x, which is 3 on 2 and -5. And the lengths AK and AM are 7.5 cm and 8 cm respectively. That is my answer.